projection operator. This takes something from a vector space, maps back into that same vector space. So again, the input and output spaces are the same. So the projection operator is an operator that satisfies what is called the idempotent property. The idempotent property is this. I have E that operates on some X in the vector space. Okay, that is going to give me something back in the vector space, which I can then operate again. So I operate again. I do an operation on the thing, and I operate again. And so I can actually write it this way, E squared, which basically means this. And this is the result. That E, when I operate on X, the quantity that I get, if I operate on E again, I just get the same as E operated on X. So that is, when I operate on this, I get itself back. So repeated operations on using E act just like E. Okay, so that is what a projection operator does. I can keep operating, doing the same thing over and over again, and I get the same result. So an example of a projection operator is the identity operator. So remember, it maps X onto itself. So the identity operator, I get X. If I do it again, I still get X. And I can keep doing it as many times as I want, and I still get X. So for any subspace M of V, there exists a projection operator that will map V onto M. So this is an important thing. We're going to see how to do some of this depending on the subspace that we have available for us and how we have it defined. But we can actually, given a subspace, we can actually find a projection operator that will do this map. If E is self-adjoint, okay, that is, it is its own adjoint. That's what this means. E is equal to E adjoint. That means E is what is called self-adjoint. So if a projection is self-adjoint, it is called a projector. And that's a very powerful tool, is working with projectors. So basically, I can think of it this way. I start with my input space. My projection maps into my input space. And notice when it projects from this initial input space over here, this Y is not necessarily the same as X. This Y could be different than X. But if I operate on this point again, I'll get Y. I'll keep getting the same value. Okay, so that is what a projection operator does. So these are important operators for vector spaces.